exterior vehicle shape. This innovative structure enables us to have flexibility in the end shape and usage of the vehicle. By changing the exterior and some interior panels, we can quickly respond to consumer demand. The drive-by-wire system and our human-machine interface system has been designed to enable software and hardware upgrades to keep the vehicle competitive for at least a decade. Most of the latest advances in vehicle technology have been in electronics. We have provided an on-board computer with enough memory and processing capability to run new packages and the ability to run new programs. Space for a hardware upgrade such as plug-in points, wireless antenna, vehicle sensors, such as video cameras for automatic driving, have been envisaged. One of the challenges was to find a method to recharge the vehicle's electric battery. With our design, when the vehicle is not running, we cannot recharge the vehicle's battery via the engine. To respond to this challenge, we've used low-current LED lighting systems, with the electric recharge being provided from a regenerative wheel hub motor mounted on the rear wheel of the vehicle.
The vehicle safety is enhanced using the latest carbon fibre reinforced crash tubes. These are manufactured via the quick-step process and provide excellent energy absorption capability in the case of a frontal impact. The use of the quick-step process allows rapid manufacture, minimal tooling and equipment costs, and dramatically reduces the cure cycle times compared to conventional manufacturing methods. Dynamic crush tests have revealed that carbon fibre tubes provide up to 5 times the specific energy absorption compared to equivalent steel tubes.
Finally, our design is completed with a project that has investigated how our vehicle would impact on future metropolises. In particular, the effects of an ecological sustainable vehicle on the resources within our vastly expanding cities. The two cities of focus for this study were Beijing and Shanghai, two of the largest urban areas in China. The increasing middle class are now able to afford cars, putting large amount of pressure on emissions, as we've seen in the recent Beijing Olympics. We propose that the new Model T Ford can reduce emissions by encouraging the use of a close to zero emission vehicle. The inner city driving would be made gas burner free zone to reduce emissions, as long distance driving within a city is unnecessary. Gas stations would be adapted to include air compressors, while separate air pumps can be provided in locations with limited space. Parking towers on small sites would be established to accommodate cars within the city and also accommodate parking for multi-storey apartment complexes. These towers can be fitted with solar panels to offset energy usage, and heat from the pumping could be used to heat surrounding buildings. In summary, our key motivation has been how to cleverly reduce the number of systems within the vehicle to save on cost while increasing the flexibility of usage. Like the original Model T, simplicity has been our objective. We have combined this with providing consumer flexibility and innovative sustainability with an almost zero emissions car.
The key points of Deakin's exciting design solution for the Model T Ford for the 21st century are: an integrated approach to achieving an innovative yet practical outcome, delivering simplicity and savings in weight and cost. The use of high-torque, compressed air, wheel hub motors with the potential to reduce vehicles' emission to zero. Differential wheel speeds are used to steer the car via hub motors, which removes the need for a conventional gearbox, driveline and steering rack pinion systems. Using the wheel hub motor concept with only 3 wheels to increase agility and manufacturing advantages. The use of ultra-high strength steels and novel manufacturing methods to increase strength while reducing weight. Easily adaptable human-machine interface to keep the vehicle competitive for at least a decade of advances in software technology. The simplicity of the design means that it can be assembled at accredited Ford dealers, which was the original business model used by Ford Australia back in the early 1920s when the Model T was first launched in Australia.
At Deakin University, we believe our design is worthy of showcasing. It demonstrates the same revolutionary thinking as was incorporated in Henry Ford's original Model T. Thank you for your time and the invitation to participate in this exciting challenge.